So this is the ripple carry adder from milestone 1. It will be added at the final schematic with prescaler after the selector. It will add the current input and the store input. And for the accumulator, so this is the output waveform for the accumulator. Every rising edge of the clocking, the clear will clear the data. And if the input is in active flow, it will store the data. For the net rider, this is the net rider. The net rider from milestone 2, but here is another output to detect the number 1001, which is 9 in decimal, and the output is in to indicate the done. So this is the output waveform for net rider. This enable, when the enable is in input high, the LED will be on, and this done to indicate that the LED is running in one loop.
So this is a schematic diagram for the prescaler. So here is the GCLK in with input for about 50 megahertz that we can get from the CPLD. So at the LPM counter 5, here we will count 36 bits value ranging from 0 till 67108863, and the LPM constant 0. Here we will set to 42108863 and to get an output value for every 0.5 seconds. So here at the T flip-flop, it will toggle when the input comes and it will output for 1 Hz. And for the at the T flip-flop, when the signal comes to create a 100 Hz, we will take about 19 bits to get a frequency around 95 Hz, which is near to 100 Hz. So moving on the simulation. So here we set it as top level entity and we will simulate. So here it states that the simulation was successful.
Okay, for comparator module, we are choosing interactive comparator. So this is one bit interactive comparator where we only compare one bit number. The compilation report is successful. Okay, for simulation waveform, the output for E out will be equal to 1 if E in is high and A and B is equal. Or okay, meanwhile for G out will equal to 1 if E in and A is high or G in is high. next is the from 1-bit comparator, we will create 4-bit comparator. So to create 4-bit comparator, we will create a symbol from the previous schematic diagram. Okay, so this is the 4-bit interactive comparator. The comparison report is successful for simulation waveform. For simulation waveform, the 4-bit comparator will generate output the same as 1-bit interactive comparator, but instead it will compare 4-bit number. So this is the output. Okay, next is the binary to BCD converter. Okay, for this converter, first we need to create the CADD3 module, which is conditional add by 3 module. Okay, this is the schematic diagram for CADD3 module. Okay, for this module, the first 5 input will remain unchanged at the output, and then the next 5, the adder will add 3, and then after that the input will be don't care or invalid for BCD. Okay, the compilation report is successful. Here we can see that the first 5 input remains unchanged, and then the next 5, the adder will add 3, and after that it will be invalid to represent BCD. Okay, then we can complete the schematic diagram for binary to BCD. The 7th segment will display the BCD output. The comparison report is successful. This is the output, the simulation waveform. Okay, so here we can see that when G is high, A, B, C, D, E, and F will be low. So from this we can conclude that this converter is using common anode.
So here is the schematic diagram for the input filter. So here we will set it as top level entity, and then we will stimulate. So the simulation was successful. So moving on to the waveform. So this is what we have set. So we will simulate. So here it can be seen that the input filter has filtered out the bounds of glitching of the switch, and it gave us a steady pulse for 1 clock cycle. So this is the selector for our group. So here at button 2, when button 2 is pressed, it will add 2 to the adder and accumulator. Same for when button 5 is pressed, it will add 5 to the adder and accumulator. So now we will set this as top level entity, and we will begin the compilation. So we see that the compilation was successful. So now moving on to the waveform. So here is the waveform output that we have set. So this is for button 2 and this is for button 5. So we begin the simulation. So here it can be seen that when only button 5 is pressed, it will output 0101, which is when in hex. When in hex, it shows the value number 5. And here, when button 2 is pressed, it shows that it will output a value 2. And when no buttons is pressed, it will show no response. Similarly, when both button is pressed, it will also shows no response.
Okay, this is the final schematic diagram without our prescaler. So here we have two buttons and then two clocks. And then this is our input filter where we filter out the glitches from the switches and give us a steady pulse. And then the selector will choose 2 or 5 from the input. And then the adder will add the number that is previously stored in the accumulator. Okay, from the accumulator we go to binary to BCD. We convert binary to BCD number and then convert it to 7-segment display pattern. Okay. The accumulator also connected to 4-bit comparator where we compared with the value 11. If the accumulator value more than 11, it will enable the night rider. Okay, so and then we run the pattern once. Okay, then the night rider will send the signal done back to accumulator and then clear out the accumulator, and then the cycle will repeat after that. Okay, the compilation report is successful. And then this is the simulation waveform. Okay, this is the output.
So here is the final schematic with prescaler. So we set it as a top level entity and run. So to assign the pin, we go to the pin planner. Here we already assigned the location for the pin and we compile it. So it was successful and to program the CPLD. So the hardware setup, USB cluster, here select all and start it. So the progress was successful. Now we're moving on the CPLD.
So we only have one 7-segment display. So the one LED on the left side of 7-segment display represent of B and C. And this is the result after we wiring up all the connections according to the pin that we already assigned.